Alright, now we're going to take trig ratios that we learned from the last lesson and apply it to solving for side lengths. Okay, and your learning target is I can use trig ratios to find side lengths in right triangles and to solve real world problems. So before we begin our key concept, I want to remind you something that we learned last video, and this is really important to understand. Trig ratios, what they do and why they're important is they help us find missing sides when we know angles, and they help us find missing angles when we know sides. Okay, that's the importance of these trig ratios here. Okay, so in order to find the length, we're dealing with sides now. In order to find the length of a triangle, the missing length, we need to first identify the trig ratio needing to be used. Remember, that was SOHCAHTOA. Okay, sine dealt with opposite over hypotenuse. The cosine dealt with adjacent over hypotenuse, and tangent dealt with opposite over adjacent. Okay, now the IE right here, what you're putting there is for sine, cosine, or tangent. Those are our three trig ratios. Those are the three really important things, and you need to memorize what SOHCAHTOA is. You have to remember that sine is the opposite over hypotenuse, cosine, adjacent over hypotenuse, and tangent, opposite over adjacent. I'm going to say this so many times because it's very important that you understand those ratios. Okay, after we do that, then we need to substitute the given values and solve for whatever we're trying to solve for. Alright, example 1 says to find each length and round to the nearest tenth. Okay, so here's how we do this. When we are given an angle and the two sides that we're missing, we need to first identify what are we trying to find out. What are these different sides based on the angle we're given? And if we know this angle, this is the angle adjacent, or the side, sorry, adjacent to that angle, and x is the hypotenuse to that angle, right? So if we have an adjacent over a hypotenuse, we know we're going to do the AH or the CAH. We're going to have to use our cosine. Cosine is adjacent over a hypotenuse. And the cosine of 46 degrees, remember that finds the ratio, should be equal to that exact same ratio as a fraction. Adjacent over hypotenuse, which is 12 over x. Okay? X is what we're trying to find out. Okay, that's what we're trying to find out. And so what we need to do in order to get x by itself is we first need to get it in the numerator. And we can do that by multiplying it by x on both sides. Because what happens is these cancel out, and I'm going to be left with x times the cosine of 46 degrees. Real quick, we're using cosine 46 as if any other number, as just a regular number. That's the exact same thing as if this was just 4 or something like that. It's a different number, it's a complicated number, but all it is just a number. And so to get rid of it, we have to divide. These are being multiplied. We're just going to divide by the cosine of 46 degrees on both sides. And so we see that x has to be equal to 12 divided by the cosine of 46. Okay? Now we can actually solve for what x is. And you cannot really do this by hand. You kind of have to use a calculator here. And so we're going to get our calculator and we're going to do 12 divided by the cosine of 46. And that'll tell us what x is equal to. So 12 divided by the cosine of 46. And if you press enter here, it's going to give you this number right here. Okay, now it said to round to the nearest tenth. That means this 7 rounds the 2 up to 3, which gives us x as 17.3. So this special function, this special trig ratio of cosine, made it so that even though we were just given an angle and a side, we could find that the distance of the hypotenuse here was 17.3. Okay, example 2, we're still trying to find what the value of x is, and we know x is the hypotenuse. 16 from this angle right here is the opposite. That means we're going to use SOHCAHTOA. S is the opposite over a hypotenuse, which means we're using sine. And we know the sine of 61 degrees is equal to the opposite, 16, over hypotenuse, which is x. So it's the same type of thing here. We're trying to solve for x, and so we have to multiply by x to get rid of it on that side and get it in the numerator on the other side. And we'll have x times the sine of 61 degrees is equal to 16, and then we just divide by the sine of 61, and that will end up getting us with x by itself. These will cancel out. I'll be left with x is equal to 16 divided by the sine of 61. And that's when we can get our calculator to help solve the rest of this out. So 16 divided by the sine of 61. 16 divided by the sine of 61. Enter. Tells us that 18.3, remember rounding to the nearest tenth, is our distance of x. X has to be 18.3. And that's how we solve that problem. Okay, last example here. It says a contractor is building a wheelchair ramp for a doorway that is 1.2 feet above the ground. To meet ADA guidelines, the ramp will make an angle of 4.8 degrees with the ground. To the nearest tenth of a foot, what is the horizontal distance covered by the ramp? Okay, so first thing we have to do is we have to draw something to help us picture this a little bit better. We're going to have some ramp go up to a certain distance, and we know that it is a degree of 4.8 degrees. It gets up 1.2 feet. Goes up 1.2 feet. And we're trying to find the horizontal distance, this, covered by the ramp. Okay, not the distance of the ramp, the horizontal distance covered by the ramp. Okay, so we have to decide, how do we figure out, based on this angle right here, what x is? And we see that this is the opposite of the angle, and this one is the adjacent. So OA means that we have to use our tangent trig function. Tangent of 4.8 will give us the opposite, 1.2, over adjacent x. Okay, now again, it's just solving to try to figure out what the distance of x is. We have to multiply by x on both sides, and we end up getting these to cancel out. I'm left with x times the tangent of 4.8. Remember, that's 4.8, not 48, is equal to 12. And then divide by the tangent of 4.8. And if we do that, we're going to end up getting this function, or this scenario here, where 12 divided by the tangent of 4.8 will give us the distance of x. That'll give us how far the ramp has to go horizontally. So again, we'll just do tangent that's not tangent, it's 12 divided by the tangent of 4.8. So 12 divided by the tangent of 4.8 will tell us that that horizontal distance has to be 142.9. 142.9. And 142.9, that's great, but remember, what is this situation talking to us about? It's talking to us about feet, and so what that means is that it's got to be 142.9 feet away. Okay, and what that does is, what that helps us do is it helps us figure out how far away do we need to build that ramp. How far does it need to start in order to get all the way up by just going up by a degree of 4.8.